everybody. Hope you're having a nice Monday. I'm gonna be rotting my brain after work with some PICO-8 Gamedev. There is the strawberry jam going on. Let me see if I can show you. Browser. Strawberry jam. Hello, browser. There is a... Oh yeah. So there is a strawberry jam going on. Oh, there's a bit spoilers on the top, but we will get to that. Not so long ago, PICO-8 Gamer and Science started a big PICO-8 Gem series, which will be probably a reoccurring one to my knowledge. That was the Create Gem. And the Strawberry Gem is gonna be the little brother for that gem, and it is gonna be hosted around major holidays like Thanksgiving, Christmas, you know, the likes. And this time, I think this is pronounced Gerald. That's what my minds also tell me. Is our host. And our theme is gonna be Christmas with the cool limitation of only 4 colors. And if you think 4 colors are a lot, they are not, because you need one for transparency and backgrounds and such. So basically, you have 3 colors, like the Game Boy. So we're gonna grab a little minigame idea. I'm gonna go up to here, and not sure why the browser is here as well. And if you are familiar with old school games and old school single board computer handhelds, they were like little Tetris shaped cars where you had to dodge them from left to right. And the Commodore 64 had I think it's called Raceway game where you had to dodge things. And we are gonna be on a similar line of thought. Our little Santa is gonna be pulled around by a reindeer and gonna dodge some Krampuses along the way. We have some trees. These are little sprites I have thrown together during the day, and we will see how we'll make a game out of them. A little simple game, nothing too complicated. A score chaser, if you are familiar with the term. So yeah, how I usually start games is I go to the code tab, and I like to declare the big three. Don't ask me why. This is just how I usually do things. We have our update, and we have our draw. And we're gonna save this. And now we're gonna jump into our usual VS Code. And this is where we're gonna be coding, because I'm not the biggest fan of the built-in code editor. It's just a size that really doesn't match with me. So yeah, first things first, we want to move around the screen. So let's do a little player that moves around the screen. For this, we will have an object called player. And we're gonna have an X and a Y positions. We're gonna start around the middle and a little off from the edge of the screen. After this, we are just gonna do little button checks. We're just gonna say if btn, which is the button code, then so 0 is the left. So if we wanna go left, we're gonna decrease the player's X position by, let's say 2, because 1 is really slow. we're just gonna do this for all the other 4 directions. So button 1 is the right arrow. So if you are going right, we want to add to the X. The up is button 2. If you want to going and the down is 3. If you want to go up and down, you want to modify the Y. And here, this is a plus because this is the up button. And now we are just gonna jump into a draw function, SPR, and we want to call, let's draw Santa. How about that? Let's draw Santa first. So Santa is sprite 1, but it is a 2x2 sprite. So we're gonna say sprite draw 1 at the player.x and the player.y. And we want to say draw a 2x2 sprite. And if we rerun our game, we're gonna see a little old school Windows glitch. This is because we haven't cleared the screen. We're gonna call CLS, and here I messed up. Upwards is so the top, which is this top left corner, is 0, 0. So if we want to go upwards, we want to decrease, not add. My bad, it's Monday night. So let's go. And we have our little Santa flying around. He can go wherever we want him to go. So now that we have our player moving around, how about we add some Krampuses to the screen that we want to avoid? So for that, what I like to do when adding objects you want to avoid is to create a new collection. How is the word Krampus in English? Does it exist at all? You almost write it how we do. Okay. And how is the multiplication for it? The same. How do you say Krampus? That's not what I want, but let's just go with Krampus collection. This is gonna be an empty array, which is the future place for all our Krampuses that we add to the game. Now, I generally like to do the other functions on top, so I will do them here. Function add Krampus. This is gonna be the function that we are gonna call. Function to call to add a Krampus to the game. So we're gonna declare a local Krampus. Let's go. And this Krampus is gonna have an X and a Y position just like us. So X is gonna be off the screen, which is something that is bigger than 128. So let's go 130. This 130 is the right edge of the screen, a little bit off from that. For the Y, we will want to have them basically spawn all over the screen. So let's just say random 110. And they're gonna have a speed because they want to move around the screen. So let's just do a speed variable for them, which is 2e and not 2d. And this is just gonna be a random 2 plus some random value. This is gonna be the speed that they will move to the left edge of the screen. After that, we have our Krampus object. Let's put him into the collection. You do that by add Krampus, collection, and Krampus. This way, after we call this odd Krampus, the Krampus will end up inside this collection that we have. So how we deal with them? Inside update, you can do a for each, which is basically for Krampus in all Krampus collection. You're gonna iterate through over the collection that you give over here inside all, and you will put each element one by one into this Krampus. And inside here, you can say Krampus.x should decrease by the Krampus's speed. Decrease because they are going to the left, and the left corner is 0, 0. After that, we want to check if the Krampus is far off the screen. So maybe it is 16. You're gonna say 16 minus 16, right? Yes, minus 16. I'm gonna tell you why minus 16 in a moment. Then let's just delete this Krampus from the game. They are not needed anymore. If you're gonna leave them inside, they're gonna lag your game. Bam. Krampus. So why 16? 16 because each Krampus sprite is an 8x8 plus an 8x8. They are 16 by 16. So if their top corner is 16 tiles away from 0, that means they are off the screen. And now we just want to throw these Krampuses on the screen, so let's grab the same foreign. And each Krampus is gonna be at the Krampus, the sprite call. Our Krampuses are at 3. Sprite 3, you check this top corner, which is 3. And it is gonna be at Krampus.x, Krampus.y, 2 and 2. Also some music. Hold on. Give me some music. Maybe this one. This is a bit too loud. And yet again 2x2 because they are gonna be 2x2 sprites. So if we reboot, nothing happens. Why? Because we don't add any Krampuses to the game. So how about every 2 seconds we add the Krampus? If time modulo 2, this is gonna, the modulo is gonna add the pass back as the remainder equals 0. So if time can be divided by 2 without any remainders, that it happens, then it's 2 seconds. Timeout, welcome, welcome. How you doing? How you doing? And we're just gonna call add Krampus. And so every 2 seconds we're gonna call this add Krampus, which is gonna create a new Krampus and gonna put it inside the collection. Let me check my notes because I think I had a higher speed for them. No, it was 1. Okay. It was the same. So now if we go back, there should be a Krampus appearing. Whoa, there they are. They are coming for us. So the game is gonna be about dodging them and maybe grabbing a few gifts while we are at it. We're gonna have a limited life where we can collide with them, and if you collide enough, the sleigh gonna fall. Like we're gonna be. So yeah. But if you are a sharp eye viewer, you could notice little totally not Rudolph inside in the spreadsheet. This is gonna be your little twist on the genre, because we are not gonna be controlling the Santa. We are gonna control the. Oh my god, brain fart! What is the word? Reindeer. That's the word I was looking for. we're gonna be controlling the reindeer who is gonna pull the sleigh around. Not in a physically simulated way, because that is way beyond what I want for a quick gem project. We're just gonna be moving the sleigh in the form of an option, for example from Gradius. They're just gonna follow us around the screen. So let's go back to the game, and since we are not gonna be controlling Santa, let's create Santa into the game. Santa should be around the same height as us at the start, but maybe he starts further back away. Maybe at around 12. You know, no, not even 12. Let's put it like 8. So now that we have Santa, we are not moving Santa anymore. So inside here where we draw the player, we are not gonna draw the sprite 1. We're gonna draw the sprite 5, I think. What is the reindeer? Yes, sprite 5. And I forgot to add... Oh, the comma was at the wrong place. So now we are the reindeer. So let's add Santa to the game. So we already see how we do that. We just call sprite 1, but now with Santa's coordinates. Santa.x, Santa.y, Santa Maria. And now if we reboot, Santa is gonna be there, but he's not following us. Well, because we are not telling the game to do that. So let's do that. We're gonna do that in a way that I did Eiffel in or sour cream, I think the English name what we have gone with. Inside Lina, Witches of the Moon, where the little cat follows you around. And she does that by the following way. We have a position, collection, which is gonna be storing past positions of the reindeer. Hold on, I have a sneeze. Back. So we're gonna store positions, and we're gonna store them in a following way. We're gonna declare a new local variable inside update, which is gonna store if we moved at all. You're gonna declare it as false, so if we don't press any buttons, it is gonna stay false. But if we press any of these, we're just gonna say that we moved. Bam, bam, bam. So now we know if we moved. So if we moved, we said that if we moved at all, store the position inside our collection. So we're just gonna translate it to code. If moved, then add position, collection, and some position, but we don't have anything called position yet, so let's create that. Local position is just gonna be a simple clone object of our x and y coordinates. So player.x, y should be player.y, and that's all. This is how we're gonna store our past positions. These are update Krampuses. Hold on, Krampus. So now that we store our position, let's move Santa. We're gonna move Santa in a bit weird maybe, but I think this is somewhat close to the original workings of options in Gradius. We're gonna say if the number of position collection. So this operator is gonna give you the length of a collection, like how many elements are inside that collection, or if you add the string to it, it's gonna be return the length of the string. So if this is greater than some arbitrary number, we want to say 10 maybe, then if we have 10 positions stored, more than 10 positions stored, then we're gonna say Santa.position, not Santa, Santa.x should be position collection, first item x. This is gonna grab this x, of one of the first positions that we added to Santa. We're gonna do the same with the y positions. And we're just gonna delete the item. We're gonna empty this one because we already moved Santa to there, so we don't need it anymore. Position collection 1. This will basically cause Santa to lag behind us by 10 positions. Not behind, behind. So now if I restart, then we'll be able to move, and Santa is gonna follow our movement. We are basically pulling his lazy ass around because we are the reindeers and we are the kings. Without us, the sleigh is not gonna move. One drawback of this kind of position position setting and checking is that if we just stay in place, the sleigh is not gonna flip around. So we are not simulating by any means a rope and pulley system or applying forces. We just simply having Santa to be behind us by 10 positions. You can increase this, you can decrease this. I think this 10 should be fine. But it feels a bit empty, right? Oh, you are really slow, my friend. You are like the slow king of Krampuses. Krampai? How the hell do you say the multiplicative version of Krampus in English? Whee! So, for a little flair, how about we add the rope between Santa and a reindeer? That is gonna be done by a simple line call. And for line, you want to say an x1 and y1. This is gonna be the first point, and the second point x2 and y2. So let's figure out what these are. Oh, and the color. So we go to PICO-8. Let's say we want the sleigh to be pulled around this front part right here. So if we go to the top here, it says 8 and 0. Then we know that the 10, or not the 10, that this 20 is basically 12 forward in the Santa sprite. So the first number, the x, is gonna be 12. Right here. So we're gonna apply the 12 here. This is the x1. And if we look at the y, it is starting from the 0 because we are in the first row. And it is 11. So we're gonna just say, hold on, we need to say Santa.x because we are always coming from that point, from Santa, or to Santa, to say. And the same way, Santa.y plus 11. Now we have our first two numbers. Let's find the ones on our reindeer. The sprites start at x40. So if we want to, maybe here in the middle of the chest, this is 50. 50 and 11. So that should be player, because the player is the reindeer, dot x. And 50 minus 40 is 10. So plus 10. And player dot y plus 11. And I'm gonna do one more thing. I'm gonna duplicate this and offset it by at y1 at each y, so it's gonna be a thicker line. Oh, that may be a bit too thick. But now we have a little line that will pull the sleigh. Let's just do one here. So now it is getting a bit thicker near the reindeer, but I think that's fine. So now it looks like we are actually pulling Santa around. We are not, but it looks like it. Whee! Oh, you were a fast one. So one more eagle eye thing you could notice are these little triangles here at the bottom. These are for pine trees. We're gonna be drawing pine trees at the bottom. We're gonna do them in the same general way that we did our enemies. So let's create a new collection. This is gonna be the trees, which is double E and not double S. Storing trees. Storing Krampus. And we're gonna create a new odd function. This is gonna be function odd 3. So what do we want to do with our little trees? We're gonna say that we want multiple levels because only one triangle will look boring. So let's create a local tree object. It should have an X because they are gonna be zooming down at the bottom. So its X should be, I don't know, 128. And for Y, we will not say anything. We will calculate this at runtime, but we want to generate how big our tree should be. So let's say we're gonna call that segments. How many triangle segments our tree gonna have? It's gonna be a floor, a random number between 1 and 4. You do random numbers between two numbers. Is you say the upper limit. Here we are flooring it, so it is an integer, and you add +1 to it. Not familiar with integers. Integers are the 1, 2, 3, the exact numbers, not like the floats like the 1.5 and such. Because if you don't floor it, random is gonna give you fractional numbers. And now we have a tree. So let's add this tree to the trees. Add the trees. 3. We can update them in the same general way as we did our Krampuses. Update trees function 3, not function 3. Oh my god. For 3 in all our collection is the trees 2. I'm just gonna say 3.x with minus equals maybe 2. We will see how fast that will be. And we want to do nothing else with the trees. And inside our draw, let me comment this. Draw Krampus. Draw Santa. draw the player. I cannot type player, reindeer, draw the line between reindeer and sleigh. Sleigh. This way. I think this is how you spell sleigh. And now 4, 3, and 1. These 2 and here we're gonna be constructing our trees from the ground up. How we do that? Well, we created a segment. So let's do for I equals 1. And we're gonna do our for cycle from 1 to the number of the segments in the tree, 3 dot segments. No. And here we're just gonna say what is the sprite? It is 32, so SPR 32. It is gonna be at the tree's x coordinate, and now we're just gonna say this tricky line, which is gonna be 128. This is the bottom of the screen, minus the iterating number, minus 1 times 8. And this is yet again a 2 by 2 sprite. What this is gonna do is that for each segment we're gonna start off, we don't need a -1 because we're gonna draw 1 screen. For each segment we're gonna be 8 pixels up from the bottom of the screen. So the first segment is gonna be drawn at 128, not 20, 120. The second is gonna be drawn at 112, then 104, and so on and so on. So if we rerun, oh, we haven't added any trees, you see? No trees, because we haven't added any. We're just gonna use the old reliable add Krampus. But let's say we want to have more trees. So let's say if let's not use time, let's use a random number. If our R&D run number is smaller than 0.1, then let's add a tree. So what is this gonna do is at each frame we're gonna create a new random number, and if that is smaller than 0.1, then we're gonna add a tree. So let's see how many trees those are. 3 dot segments. Oh yeah, we don't need the length, I'm just stupid. 3 dot segments is a number in itself, it is not a collection. So we're just gonna say simply 3 dot segments. And now we have trees. Oh, you cheeky one, you hid behind the trees. So one last thing to do is, if you can see on the spreadsheet, we have tree with some snow on it. So how about the top of each tree is gonna be a snowy one? For this, let's say local sprite to draw is 32. This is our base tree. But if our I is equaling to, hold on, where is my I equals 3 dot segments. So we are drawing the last triangle. And let's say that the sprite to draw is gonna be not 32, but this one here, 34. 34. And inside the draw call, we're just gonna say sprite draw. And if now we run, the top of the tree is gonna have a little snow on it. Now we have a little forest under our sky. And yeah, this is gonna be the base look of our game. Maybe we want to have some stars. Let's try to do some stars. We already have seen how to add stuff to the game. Stars. We're gonna create a stars function. And we're just gonna say function add a star. Local star should be off screen at start. They should have a random Y position, but maybe not all on the screen. So let's just go for like a 100, the first 100 top of the screen. We're gonna move all stars with a constant speed, like our trees, so we are not gonna generate one for them. But stars, star. And now inside update, we want to have more stars than trees, right? That's one thing we can agree on. But trees, on the stars. If random smaller than 0.5, maybe we're gonna see how many stars that's gonna be. Odd star. We're gonna have a problem, but we're gonna discuss this. If you already see what we are missing, then good for you. Write it down in the comments or in the chat. Update. Not update. Draw trees. So for the stars, we just want to say a single p set. Just want to set a single pixel to the star. And we're just gonna say p set. This wants an x and a y and a color. So x is star.x, y is star.y, and color is 7. So let's move our stars. Update stars. For star in all stars 2. Star.x would equals a fairly slow number because they are in the background, they are really far away, so they should move really slowly. Maybe that's why we don't want to add more of them, but we will see. And if they ever manage to get to the other side of the screen, star.x is smaller than 0. They are a single pixel, so if they are at -1, we cannot see them anymore. Then delete them. Delete stars, star. So if you rerun, start.x. Oh yeah, I typoed. It should be start.x. Well, those are many stars. We don't want that many stars. One other problem is if we press Ctrl P, we're gonna have a little performance thing up here. It shows how PICO-8 is doing with performance, and you can see things slowly, ever so slowly ticking up. That is because we don't delete our trees. If you don't delete things from the game, they are gonna like the game. So trees are yet again 16 wide, just as the Krampus is. So if 3.x is smaller than -16, then delete trees 3. And we don't want that many stars. Add it to the game, so Let's pull back on that. Let's see how that looks. Oh wow, even that is it's kind of much. Huh. Well, let's go even lower. Point 1. So you can see that the screen is slowly filling up with stars. That is one issue we can note down. It is because we don't have any stars starting from the main part of the screen. They always start here off the screen, like here. I think these many stars are nice. I can go with these many stars. Maybe a little less, but do we go with 0.5? At 0.5? Just 0.05. How many stars that is gonna be? That's definitely better, I feel. So let's fix our starting star problem. The start of the game is the init. So let's say that inside init, we're gonna say for I equals 1 to maybe 100 stars. Do. And we're gonna say local star should equal to x should equal random between 0 and 128, and y should be a random between 110. And we're gonna start with these stars already in the game. So we're gonna say add stars. So as soon as the game starts, we're gonna add 100 stars into the sky. Let's see how that looks. And I messed up something? Apparently. Because there should be some stars on the screen. Oh, that's what I missed. We don't have our collection yet. I think if I just move this down here. Yeah, now we have stars on the screen. So the issue was that this was up here, and at that point we wanted to add to the stars collection. But that was up here, and we created stars down here. And PICO-8 was like, I don't know where to put them. So he didn't put them anywhere. Add initial stars. They're a bit too dense, so I'm gonna pull this down maybe to 60. And now we start with stars, but that is harder to say than I imagined. And we have a little snowy sky. One thing is that I want to throw the stars behind everything. They should be the very, very back of the screen. So we're gonna move them to the top here because execution is this way. They're gonna be drawn first, then the Santa, then the player. Stars. So now if you see, the white dots don't appear in front of Santa. Or anything else at that matter. And we can hide behind trees. We little demons can hide behind trees. Everyone can hide behind. Maybe I'm behind your tree. I might want a little moon on the top right corner. So let's go with a little moon. We're gonna say moon, circle fill, 110, 10, 10 is too much, 5, 7. Ooh, and we have a little moon. Man, we are progressing so fast. Maybe that moon can be bigger. That's gonna say 20, 100, and let's have a big moon. Oh, this is such a big moon. Do we want to have little shadowy circles on the moon? Maybe, but that's for another time. So, now that we have our little night sky and the Krampuses and the sleigh flying around, how about we will do some collision? Because we want to collide with the little demons. So usually the issue with that, well, we will see. I can show you. We're gonna grab a simple AABB function, which is short for axis aligned bounding blocks, I think. So let's create our collision function. Maybe pick it up here with update function collide and A and B, two objects. This is good. And now what we're gonna do is check if these objects are far enough from each other to not collide. For the moment, we're just gonna say the following. So our first object's box is basically local A left. This is the A.x, this is the top, this is the right side of the object. Local A top is the Y position of the object. Local A right is basically A.x plus the width of the sprite. We have 16 by 16 objects, so let's add 16 to it. Local A bottom is AY plus 16, and we're gonna just do this the same for B. I can do this. You can control D and search for the same phrase that you have selected. So now that we have A and B, we should check if they are colliding. These are the boxes that gonna align our objects. So to be honest, checking if two things collide is really hard. It's not that easy. So how about we check if they don't collide, because that is much easier. Why? Because you can say, for example, if a top is greater than b bottom, which means if the object's one top part is lower than the b's object's bottom, so it is below, then they clearly cannot collide. Return false. Same goes the other way. If b dot top is greater than a dot bottom, that means that the b is clearly above, not above, below the a object. They cannot collide. And we do this with the sides as well. So if a left is greater than b right, which means if this side of Santa Claus is further away on the screen to this direction, the right, then the Krampus is this side, which is the right, then they clearly cannot collide because the Santa is somewhere here on the screen. So yet again, they cannot collide. They are too far. And we're gonna say the same for the b. b dot left is greater than a right. And return false. And these are the clean they cannot collide options. So if neither of these happen, they are in some way they are colliding. We say return true. If you want to have more explanation on this than what I did, chat. Jet is here. So if you want more explanation on this AABB, this is basically an AABB or axis aligned, I think it's called bounding box, but let me look it up quickly. I'm pretty sure it's this line, ABB. Axis aligned bounding box, yes, I was right. So if you want more explanation on this, you can either check, if you need more info on this, check Nerdy Teachers has a cool video about this, or check out Lazy Devs. What is the Devs Academy? They have a much more detailed video explanation on this with actual drawings, so you can see things and not just hear and believe me. So now that we can collide, let's have a live so we can see something happen. So where's our player object? Here is our player object. So let's add live here. For example, we start with 3. And this is... And now inside our game function, when we are updating our Krampuses, let's check if collide Krampus and Santa, then so if you have collided with a Krampus, then let's say our life is player.life should minus equals 1. So let's subtract 1 from the life. How we are gonna see these lives? That is quite easy. If you come down here, let's say for I equals 1 player dot life, no, and we're just gonna We're just gonna print. There's a little heart emoji. Let me find it inside PICO-8 ASCII. PICO ASCII. We have a little character for heart. Then I don't have to draw one. Here it is. Looks like this. Let's print this heart at 2 plus e times 6, and at 2 maybe, and with color. So now if we rerun this whole thing, oh yeah, freeze the green. I wanted to do the red, which is what, 8. You should know it because I really don't like it. Did my backspace broke? It wasn't picking up anything. And just so I can show you something, let's print also this player.live at like 15, 2, and yet again with the same red number, red color. We need more than what? Hello, but not yet, not yet. Not yet, but we are starting to get close. Now if I go here, you can see that we have 3 lives and 3 little hearts. We have one issue with our collision, and you have seen it there. We have like, what, -6 life? What? -6? That is way too much. So let's come up here yet again. You see, as long as they are crossing Santa, they are subtracting from our life. We don't want that. We want the player to have some room to move around, to save their skin after they get hit. So we go back up our player object. Going in. And we're gonna introduce a new thing to our player. We are gonna call this invulnerability. Vulnerability. Gonna be 0. This is gonna set our frames. This is gonna be storing frames where we cannot be hit. Why? Because we're gonna say, if we go down here, this is when we are getting hit. We're gonna say player dot invulnerability should equals 30. What is this 30? This 30 is pretty easy. This is gonna be 30 frames of invulnerability, which is 1 second. After you get hit, you will have 1 second to move away before anything else can hit you. You can add that check here. Invulnerability is gonna be less than equals 0. So now only collision is not enough. We want to say that our invulnerability frames, I think they are called also invincibility frames sometimes. I think for some reason I used this, but I think they are interchangeable. So we're gonna say that we can only get hit if we are colliding with a Krampus and we are not invincible. But for this we need to decrease this number, because as of now we don't decrease it anywhere. So if we go up here where we are controlling our player, it doesn't matter where you do this. I just like to put it here because this is tied to the player, like it is something that the player does. So here we're gonna say if player that invulnerability is greater than 0, then at every frame we are gonna subtract 1 from it. Player that invulnerability minus equals 1. And just so we can see this invulnerability inside the game, I mean, let's show you to you first. I think this is gonna work. So let's pull our little Santa into this demon. Oh, we have an error. Oh, can you notice the error? There is if collision Krampus, Santa and invulnerability less than 0, then attempt to combo a nil with a number. Why it is a nil? It is a nil because if we go back to our code, it's complaining on, where's that line? This line. This invulnerability is nothing. We haven't said invulnerability anywhere. This is not invulnerability in plane. This is the player's invulnerability. This is how you call an object and get a value outside of it if it has it. So this way, this invulnerability is telling the PICO-8 engine to grab this value out from here. So let's save and reload. Go back to PICO-8, and now if we pull Santa, you can see it only distracts 1, subtract 1 HP. Bam. Bam. So how do we restart our game that we are dead? If you're eagle-eyed, you can notice that everything that we have declared is inside the init. The init functions, one of PICO-8's big function. This is what happens when you start a card. This is because you can do the following. If player.life minus equals 1, so if we have lost life, check if player.life is now equals 0. Because if it equals 0, I think you can just say init. Init, bro. That's bad, init. So that now we have that loaded. Let's pull our Santa into some demons. 1 HP and the game should restart. Boom, and we restarted. And that is how you have a simple game loop. We're gonna add more into this. So you're not gonna leave at this. But at this point it is almost cute little game. But we don't have a menu system. We don't have a score or things like that. So let's do those. So how you add the menu system to the game? You do it by the following, or how I like to do it. You can do it in many ways. What I like to do is have a state inside init, which starts at menu, and we're gonna have different possible values for it. We're gonna have menu, we're gonna have game, and we're gonna have an end screen. So after this we have a state. We're gonna divide from this update, and for each of those states that we want to have, we will create a new update. We will have a distinct update for the menu, we're gonna have a distinct update for the game, and we're gonna have a distinct update for the end screen. So if state equals menu, then let's call this update menu. Else if state equals game, then update game. Else if state equals and let's call it game over. Game over, then update game over. If we would run this, we will get an error. Attempt to call global update menu, because we don't have an update menu yet. So let's create one. Under update, I like to do it under update. We're just gonna create 3 new functions. Function update menu. And can you guess the 2 other one? We're gonna say update game and update game over. And in the same way, we're gonna divert our draw function as well. So we can draw different things in the menu, different things in the game, and different things in game over. So I'm just gonna copy and paste it here inside PICO-8's draw function. I'm gonna paste this and we're gonna modify it just slightly. We're gonna have a draw menu, a draw game, and a draw game over. This way you can copy this, go under the existing draw call, and create these new functions. Draw. So now if we start, we're gonna see probably nothing, if that was my guess. Oh no, we are seeing a game. That is because I haven't moved our game logic. So what we did so far is our game logic. So let's grab all these that we had in the update. So update is only these new functions, calling these new functions. And inside update game, now we want to have this code. Same with the draw. All this draw code down here that we did is for the game, not for the menu. So we're gonna just Control exit out of here and bring it into draw game. And now, just for the sake of it, I'm gonna say print state, not up here, down here. We can see where we are. I'm gonna say print state 120, not 120, 2, 126, and 8. So if you now restart, we don't have a CLS. We're gonna clear the screen, CLS. So now if you restart, you can see the menu on the corner, because we are inside the menu. But nothing happens because we don't do anything yet. So how about we start the game if we press X? We want to start the game, right? So let's say inside the update menu function, we're gonna check if BTNP, this is the button press, and I think X is the 5. Then this is how you can jump between states. So now we are in the menu state. We're gonna say state equals game. That's all. Just so this is prettier, we're gonna do inside draw menu, CLS, we're gonna clear the screen. We're gonna say print strawberry jam. We can just put it somewhere for the time being. We're gonna say to press the X button. I'm gonna dig up my X character. Press X to start. And this is gonna be at like 40, 40, and with 8. So if we reboot our PICO-8, we have Strawberry Jam and press X to start, and if we press X, the game is starting. So now we can go from the menu to the game. Now let's go from the game to the game over screen. So we already know how to do that. When our life is less than 0, we're just gonna say state equals game over. I hope I have it like this. Let's check. We need to check if those texts. Can you see? I have it this way. So let's use camel case, because that's how I like my variables. So these need to match. So if we did, let's switch the state to the game over. And inside game over, we're just gonna say if btmp 4, let's say 5, then we're gonna restart the whole game. Not even restart the whole game. Let's just say state equals menu. I mean, the best is in it. Hold on. Because how we have set things up yet for the time being. And we want to say inside the draw game over to print game over 2028 print press not game over. I need my X again from my notes. Press X to restart 38. And just so even actual score to work on, let's add a score to the player. Where is it? This is gonna be score equals 0. And when we die, not when we die, we're gonna say what are our little stores. So maybe at every 2 seconds, we're gonna add 1 to the player score as well. Player dot score plus equals 1. And in game over, we're just gonna say let's put this to 40 print score you can append to the string by using dot player dot score 38. So now we are in the menu. We can start a little game. You can see that we are inside the game. So let's pull our unfortunate Santa into some Krampuses. And we are inside game over, but we forgot to clear the screen. That is one important thing to do. CLS. And also we forgot to edit. Remember that we updated this up inside update. To have Pico, we need to do this here as well. So let's try to find some Krampuses. There is 1, there is 2, there is 3. Game over, score 4, press X to restart, and if you press X, we are back to the menu. And this is how you have a menu system where you can loop around and restart your game. Score 3. Or Santa getting pulled around into Krampuses. You deserve it. Lazy bastard. Only wanting to work at one day of each year. What? It would be maybe nice to see our score. So instead of printing the number of our lives, which we can see by clearly the number of hearts, let's say we print player.score and just down below it. And let's say score, player.score. So now if we reboot, we have a little score counter here, and it is going up slowly. And at this point, you basically have a very small little minigame. Is it difficult? Not really. Can we make it difficult? Hell yeah. Let's see how. So how about our Krampus is gonna be speeding up, maybe. So you have to be more tricky. So as time elapses, we're gonna speed up Krampuses. This is just an example. You don't have to do this. This is just an easy example. So when we are calculating our speed, let's say we're gonna add to this time, which is the time since the cart has started. Time times, not times. Let's divide time by 10. So it is going up by 0.1, 0.2, 0.3, and it is gonna be ramping up quite fast. Even now. Let's get him away. Oh, you see, that guy was quite fast, and that one as well. Whoa. Look at that speeding. I already lost 2 HP, and yeah. So one issue that you can see is we haven't restarted our game. Oh, we did within it. Now I learned something. I thought the time is resetting when you are calling in it. Oh, you probably need to call reboot or something else. We can circumvent this by creating our own timer. Timer equals 0. And we're gonna say inside update game. Oh, we need one more. We need a tick. You can call this frames. We can call this many things. Tick is equals 0. Why? We need this because every time update is running, we're gonna say if tick is greater than 29, and then tick equals 0, timer plus equals 1, and we're gonna say tick plus equals 1. This is gonna basically loop around tick between 0 and 29, and every 30 tick, which is 1 second. So PICO-8 runs its update in 30 times per second if it can. Or we can try 60, but that is later down the line, let's say. So at every 30 ticks, a second elapsed, so we add 1 to the timer. And up here, let's just say timer so you can really see how fast this can add up. We already look at them zooming. Boom. You can barely even see them on the screen. Like, dodge this. One other strategy you can do is to spawn more. Whoa, I didn't even see that guy. So let's just say this is timer.10. So it is ramping up slowly. And down here, when we are spawning a Krampus, we can... How do we do this? Do we add more? Let's say we want to add more, right? So we're gonna say local Krampus to add equals timer times 10, and we want to floor this. Let's do it by 5 so we can see it. And here we're gonna say one plus. So we always want to add at least one, right? We're gonna say for E equals 1 Krampus to what? 2 other Krampus. So there is 1. There is also 1. Oh, there is 2 now. Hold on, why is there 2 now? So soon enough there should be 3. Oh, there are now 3. So yeah, these are all ways you can make your game harder. You can speed them up. Oh, Jesus Christ. You can speed them up, you can slow them down. We're gonna refine a few more things down the line. Because if I restart and try to make a quick scope down here, you can see that we're gonna collide with the Krampus even on places where you don't see, like where you right there, because our collision is checking this whole box. That's why we have a 16. So if a Krampus, so this is the whole box for the Krampus, this big box. So if this little corner pixel, this down here, makes it into this corner pixel up there, to the Santa, we take a damage. But that is clearly something we don't want. So probably on the next stream, we're gonna see how we can refine these collision boxes. So maybe we just want to have our Santa collide here at the face. Because the sleigh doesn't care if a Krampus collides with it, but maybe Santa doesn't mind it. And maybe for the Krampuses, we don't want to use this whole big screen, but maybe just the body of the Krampus, just this part. And we can all do this by code. And that is what we're gonna do on the next stream. So let me pull this up quickly, where we did end up today. And yeah, we have our little play pulling game. We have life. We don't have a way to regain life, but we will soon add maybe presents that we can pick up that will allow us to gain more life. Whoa, I didn't manage to pull or something through there. Wow, whoa, that was some MLG gaming. Oh, I lost life. And we ended. And this is our little game project for now. Say 30 seconds. Back to coding thing. So yeah. And with this, I think I'm gonna end this little stream for today. Monday and Wednesday are quick streams, and when I can, Saturdays are the long ones. So thank you everyone who joined. I have many other projects going on, that we will continue after this one. I think we can finish the game like Wednesday or at least on the weekend for sure. Oh, hold on. I needed to drink a bit. But yeah, this is gonna be our base game. I think we have 4 colors, right? It's black, white, red and green. This is 4 to my knowledge, but someone can correct me if I'm wrong. So yeah, we're gonna do some to-dos. How about that? To-do. Refined. Collision box. Odd way to regain health. Odd. Some stuff. We need the music. Odd SFX. Sound effects and music. But the base idea of the game is gonna stay the same. We're just gonna be pulling around Santa, trying to avoid Krampuses, maybe try to avoid the trees, we will see about that, but I don't think I'm kinda on board with that idea. So yeah. Thank you for everyone who tuned in. And I will see you on the next stream. With more sleigh pulling, more Santa, more Krampuses, more moon, more stars, more everything. So thank you for being here. I hope you have a happy rest of your day. See ya.